This conference will now be recorded.
Good morning, everyone. My name is Joachim, and welcome to this webinar about security leaks inside third-party code. So today we will describe a little bit about a solution called Code Sentry. My name is Joachim, and I also have co-workers in Denmark and in Finland, Henrik and Marco. So if you are interested in this solution, please let me know, or let them know as well if you're calling in from a country than Sweden. So I will give a short introduction to know-how and to Grammatech that develop this solution, and a short introduction to software composition analysis. And then I will show a short demo of this Code Sentry solution. So if you have any questions, just put it in the chat and I will try to answer that probably afterwards. So this will be recorded, this webinar, so you can have a link to the recording afterwards to show, watch again, or to show colleagues. So know-how is a company that works in the Nordic area. We are mainly having tool solution and trainings for embedded engineers. So we have compilers, debuggers, and these kind of things. We have static analysis tools, testing tools, unit testing tools, but also different interfaces to CAN, to Bluetooth analyzers, and a lot of things that embedded developer needs. So since 2012, we have been working with Grammatech, and that is an American company. So they are focusing on static analysis, mainly of source and also binaries. And this is to detect security vulnerabilities and also faults or errors in the code. So basically, it's headquartered in Bethesda, and it has developing facility in Ithaca in New York State. So basically, they have been around for over 30 years doing static analysis, and for 15 years they have been developing application security testing products. I think their main product is Code Sonar. That is a source code analysis tool. And then a quite new thing that they are developing is this Code Sentry, that will look at known vulnerabilities in third-party or open source code. So why are we having this seminar or webinar? We all read this about attacks frequently every day, vulnerabilities in the software code and so on, and security leaks and this kind of thing. So this is quite important to manage when you develop software. And how do you develop software today? Yes, the first party, that is what you develop by yourself, and the second party is that if you have some subcontractor that develop to your specification, but more and more software are using third-party code, open source code or commercial off-the-shelf code to include in their application. Basically, you save a lot of time to reuse components. So about 96% of software reuses components, and 40% of these components contain some vulnerabilities. So how can we know what's inside third-party code? So when we should have a risk mitigation, we need to know who wrote the code, what's contained, in the code, how old are the components inside, and so on. And most people can see that, oh, who wrote the code? It's either us or some subcontractor, or we got it from some open source project or vendor. But it's going to be more difficult to say what's inside the code and how old are these components, and is there any vulnerabilities in this code, and also what about the software licenses, which software license is used in this software. So there is no way to measure outstanding risk without knowing these things. So if we look at the total iceberg, you can see that this picture illustrates it's a component that is the ICS firmware, and that contains some part of some RTOS and also some other components in the peak here. But it's very difficult to say which license is this and which version is used and so on. It's almost impossible to keep track of what's inside the software code. So when you develop software code or have open source code, you can look at the source code level, and you can scan the tools by, like for CodeZoner, and find 0 days vulnerability. That it means that you can see directly what's wrong in the code. So if you do a software composition analysis on source code, you also get identified which components this open source project comes from, or this code comes from an open source project, and which components is used and version and so on. And then you have a list of the known vulnerabilities. But when you're working with second party and third party code, you often only get binaries and libraries, and then you get a software bill of material from a vendor, because the vendor is obligated to specify what's inside the code and what kind of license is used and so on. But it's quite tricky to get this updated. So here are some examples. Your own code, for instance, you have a third-party code, you have an open source code, second party, questionable, zip, and also this work that is in third-party RTOS. So when you look at this parts or components that you're using, what should you ask to find out this? So first thing is, what did your developer reuse of use of this? What's inside the third-party codes? Are there any open source licenses that we should consider? Are there any dependencies regarding OpenSSL? Is the correct number, version number used, and so on? And this can be a very tricky thing to do. But what Grammatech is doing is that they have this scenario that you have an insufficient bill of material, you have only a binary, and you don't know how to treat it. So this is the challenge they put up to when they started to develop this code-centric software. Most of security vulnerabilities are found today by doing penetration testing or pen testing, but it is very tedious work. So when you find something and patch it, you probably have a new vulnerability exposed. So it's an never-ending race against this one. So CodeSentry was made with this challenge in mind. So the CodeZoner gets some money from Department of Defense, and they started to look at how they can use their binary scanning technology to identify this kind of problem. And they have launched now application called Code Sentry that is probably 2 or 3 years old at the moment, and that could be on premises or also a SaaS solution. So how does it work? Well, they have a binary as an input, and then they do some semantic checks and with machine learning to find out what kind of component there is in the binary, also the version of the component, and then it's mapped to known vulnerabilities. So this is a quite advanced thing to do, and it's also provides a compiler independence solution. So basically you can see that you put your binary into this and you create a software bill of material of this binary, and then you get a vulnerability list for each component that is identified. And then you map it to the known components database, like NVB and other databases, where you have published known vulnerabilities, CVE. And then you can also have a private component database if you scan your own code and this kind of thing. And you can also have cached application database. But today I will only show the known components database at the moment. So there's actually 2 modes you can run Code Sentry in, either a fast mode with checking bytes and hash tables and hash signs and strings and symbols and so on in the binary and identify that with open source components mainly. And then you have a more deep detection where you perform some more disassembly of information, and then you get a more vector based thing. And by doing this you can also find 0 days vulnerabilities, that is vulnerabilities that is not connected or known today, but it could be a potential issue. So it's quite easy to use. I will show this in the demo, but you basically put up a file that you should scan, and then you get a result, and then you can see what's inside the result. So and then all this information is mapped to different CVEs and CVSs or source to identify how serious these are, which kind of mitigations you could do if there is any, and so on. And there is also an indication of what kind of license this component are using. So source code or component source software component analysis is not just for source code anymore. So you can actually find out the binaries, what's inside. So it's quite easy to use, and it's quite good result from this. So I will try to connect to site here. Hopefully I'm still logged in. So this is a partner demo that we have, since we are partnered with Grammatic. And this is the latest version 3 something. So basically what you do is that you put here, and I will have a name of a project. I will I just find out that I will scan. We have this virus program at know-how, so I will just pick out this DLL that is antivirus program running, and I just start a scan. And what happens now is that the binary is uploaded, and then Code Center will start to analyze this. So it was quite fast, this one. I think it's not finished. Yes, it's finished yet. So what you get by running this DLL is that you have 2 different components that have been identified. One is something from Microsoft, non-runtime DLL, and then you have also some opus that contains some vulnerabilities. So what you get is a bill of material. Either you can have it as a Cyclone DX format, or you can get it in a PDF format, or how to say CSV format. So if we look here, you can see that, okay, here we have this component, this version. It's matched high to this component. It has found these vulnerabilities. It has this score and some information about the problem with this vulnerability. If I go back, I can see that I can also provide a more, how to say, executive report. So I also got some scores, how to say, included in the report and so on. So basically, in this case, I have the overall score 7, and that could be between 0 and 100. So the higher quality, the higher score. And the 7 here is depending on what's found in the report or in the scan. So here you can see that this is what is found. We have this in this opus component. We have a match to this CVE, and you can also see that the remediation. And there is one thing you can do. It has been fixed, and probably you can upgrade these components to get rid of this vulnerability. So I will also show some information here. Here you can see that this is disclosed in 2016, and it's also solved in November 2016. You get some classification of the vulnerability, and you can also see which product that is affected. You have some Apple OS, Apple TV, Mac OS, BlackBerry. So this is Android and Visual and so on. And you can scroll down, and you have also this opus component that was identified in this antivirus program I just run. And yeah, I can see that here at version 1.1.3 is affected, but it's not affected in the 1.2 version, and the identified version is 1.4 here. So it's probably I have this vulnerability in this virus program. And you can also see more information about this vulnerability. So basically what you do is that you scan your DLLs to find out what components are used. You get a bill of material, and you get some advice how to mitigate this risk or remove these vulnerabilities from your code. So basically this is how Code Center is working, and I think that is also my last slide. So I put half an hour, 30 minutes for this webinar, but we still have some time for questions and so on. So if you have any questions or do you want me to show anything else, just let me know via the chat. I think was this something you expected to see in this webinar, or did you expect to see something else? Or, do you have any questions? If you would like to look into this solution, you can put up and try some of your components that you are interested in. You can do some scanning, and also the price of this solution is based on the number of scans. So yeah. So it's hard to say how much it will cost. So it's better to have a discussion of what you have, and then we can see how you will use it. Okay, I think there is no question at the moment, so let's end this webinar and get in touch with us if you want to know more. Thank you very much for everyone who joined. Bye-bye.